Hi, welcome back. In this video, we're going to talk about quadratic functions and how we can change them and manipulate them through different transformations. If you see here on the right, this is what a quadratic function looks like. It looks like a U, it's a parabola, and we're going to be adding to this equation, this y equals x squared, and we're going to manipulate it. I'm going to show you here on the calculator how we can add some things to it or subtract things to this function and how it's going to affect it through what we call a transformation. We're going to go through a series of 4 transformations. So if you have a calculator, let's take that out. If you're not, let's write some of this down. Let's get to it. So we're going to go through 4 different sliders, A, B, C, and D, and we're going to manipulate this equation, as I just said, to see how it's going to be affected through every transformation. Let's start with the first one. Now, we have a general function here, f of x, being x squared. And this is what our function looks like. It looks like u. We're going to move the slider and figure out what happens when you add something to the function. Okay? If we start with 0, well, then it starts at the origin, which is 0, 0. But then as we start manipulating it and moving it, notice how as we increase, as we add positive numbers to it, right, the function moves up that many spaces. If you move it down to the negatives, or you subtract, let's say we subtract 3, then you're going to move down from the origin. This dotted line is the original one. We're going to move down 1, 2, 3 units. Okay, the vertex shifts down 3 units. The entire function will shift down 3 units when you subtract, and as you add, the function will move upward, however many units. You can do as much as you want. We're going to stop here at 4. If I can get it to stop at 4. Anyway, you get the picture. Here's where we want to go with this description. Okay? Whenever you add a number to the function, f of x plus a number, if that number is greater than 0, we can say this is, as an example, f of x plus 3, then that means that the function is going to move up 3 units. So we call this a vertical shift. This is a vertical shift, and we're going to move up. Let me just erase this real quick because my handwriting is a bit off. Vertical shift up 4 units. Okay. Whenever the function is less than 0, like in this scenario right here in the middle, if the number is less than 0, right, we're now subtracting. So that function, if we do f of x minus 3, it means we're also going to do a vertical shift. But instead of it moving up, since we're subtracting, we're going to move down 3 units. And I just realized this should have been a 3. If we're doing plus 3, it should move up 3 units. If we did plus 4, it would have been up 4 units. Now, what happens when d equals 0? We're going to change this back to 0. I can't seem to get it to 0. Let me see. There it is. If the function is adding 0, then it doesn't move at all, right? So f of x plus 0, it doesn't shift vertically or at all. It's just the parent function. So we'll call this parent function. Because it's at the origin. Nothing is changing. There's no transformation when you do plus 0. All right, let's check out the next transformation. Now we're going to look inside the parentheses. What happens when we do something here? F of x minus c. Inside the parentheses, we're going to subtract. So Notice how inside the function I have a plus 0. Let's answer that question real quick here at the bottom. When you add 0 or subtract 0, plus 0 or minus 0, there's no change. This is the parent function. The parent function is the original function, right? X squared. So there's no changes. Now let's look at what happens when we do plus, the positive. Right? If we move it to positive 3 as an example, here in the thing I'm looking at c equals 3. But notice how inside the parentheses it's minus 3. This right here is you're subtracting a number. So if you're subtracting a positive number, what happens on the inside? What you're really doing is you're saying x minus 3. So we're going to actually move in the opposite direction inside the parentheses. So minus a positive number means you're going to shift this function 3 units to the right. So this is called a horizontal shift. Three units to the right. And now let's explore what happens when you do, instead of a minus 3, we do a plus 3. Now it's going to move in the opposite direction, right? So now we have plus 3 means 3 units to the left. Now, I know what you're probably thinking is like, well, why is plus 3 move to the left, and why does minus 3 move to the right? Why is this opposite behavior, right? How come when we have a negative 3, it moves to the right, and when we have a positive 3, as you see here, plus 3, it moves to the left? Well, if you think about it, the function is minus a number. So if you start to subtract, if you do, here, let me erase this a little bit. If we put a number in here and we say f of a number minus a negative, what happens when you subtract a negative? This changes to positive, right? That's why subtracting a negative changes to plus. Moving it to the left, to the negative side, right? Moving it to the left, subtracting a negative changes to plus 3. And that's why we're doing the opposite behavior. So we call this a horizontal shift. And because it's positive 3, we do the opposite. 3 units to the left. So inside the parentheses, we want to look at the opposite behavior. Okay? If we have minus a number, we're going to go to the right. And if it says plus a number in the parentheses, we're going to go to the left. It's opposite behavior. Opposite behavior is what you want to remember inside the parentheses. All right, let's talk about the next transformation. Now we're going to be multiplying the function times a number. Notice how there's a number, the letter a in front of the function, so it's a times f of x. Now we're multiplying the function times something. So what happens when you multiply it times something bigger than 1? Something between 0 and 1, when it's equal to 0, and when it's less than 0, okay? And if you think about it, right now we just have a 1. So there's no change. This is the parent function. The parent function is 1x squared. This is the parent function. So 1 starts at the origin and it's pointing upward. If we increase this value and we say multiply it by 2 or by 3, right, what ends up happening is that this value starts getting stretched. Notice how this parabola starts to get narrower. It starts getting skinnier, okay? We call this a vertical stretch. Kind of like when you wake up in the morning and you start stretching, you raise your hands in the air. That's really what's happening with this parabola. It's stretching vertically. We call this a vertical stretch. So whenever you multiply by a number bigger than 1, it increases. So it gets narrower. And if you think about it, multiply anything times 2. Multiply your age times 2. What happens to your age? It goes up, right? What happens when you multiply your age times 5, like in this scenario? It also goes up. So these numbers are going to be stretched higher vertically. So let's just say we have 5 times f of x. And it could be anything bigger than 1. It could be 2, 3, 4, 5. All right. We start at 1. Anything bigger than 1, whatever you choose to multiply by, it's going to vertically stretch by a factor of 5. What happens if let's skip around to less than 0? Well, let's go before we get to the 0. We have bigger than 1. Let's make these numbers a little bit smaller. We're going to go back to the original parent function where it's equal to 1. And now we're going to look at just numbers between 0 and 1 because we still want it to be positive, but now the number is going to be between 0 and 1. As I start to lower this number, what happens to the parabola? Yeah, it gets wider, right? So instead of saying it's narrower or skinnier or vertically stretched, now we're saying this is a vertical compression. It's going to compress. It's going to get wider, okay? And the lower the decimal or the lower the fraction, right? Here, let me move this a little bit higher. The wider it gets. So any number between 0 and 1, it can be in a fraction form or it can be in decimal form. When it's between 0 and 1, let's just say if we're using 0.3, we can say 1/3 as an approximation. Or you can even do 1/2. What happens when you take half of your age? Age is going to get smaller, right? It's going to get what we call a vertical compression or wider. By a factor of 1/3. Okay, so far we've done vertical stretch and vertical compression. It stretches when it's bigger than 1, and it compresses or it gets wider when it's less than 1. Of course, we're still dealing with positive numbers. So decimals or fractions between 0 and 1 is going to be a compression. It's going to keep this wider, right? Whenever it is bigger than 1, it's going to get stretched. Vertical stretch versus vertical compression. Now let's talk about what happens when a equals 0. Well, if you multiply anything times 0, it's just going to equal 0, right? 0 times any function. Okay, let me change this color. 0 times any function, quadratic, linear, anything, it's just going to change it to 0, right? So the function just equals 0. If you multiply by 0, the answer is just 0. So it changes shape completely, right? It goes from being a parabola to just being a horizontal line. That's what ends up happening. Okay, and here we have 0 times f of x. Now let's look at what happens when it goes into the negatives. What happens with the parabola? Our original parabola is up here at the top. It's pointing upward. If you take whatever function, especially this parabola, and you make it a negative or you multiply it by a negative number, what ends up happening is it flips it over. Now all of these positive numbers that used to be up here, right, in the blue, get flipped over to be negative. You can think of this as a happy face when it's positive, sad face when it's negative. If a number is being multiplied by a positive number, it's going to point up, right, like a happy face. When you have a happy face, the smile is going up, right? You're positive. We like to think that people that are positive are usually smiling. People that are negative are usually not so happy. They're frowning. Notice how the lips are pointing up or they're pointing down. So whenever you multiply it by a factor of a negative value, let's say negative 5 to keep it the same, right? Instead of positive 5, we're going to say negative 5 times f of x. Any negative number, or let's just keep it generic. Some negative number, whatever negative number it is, it's going to reflect over the x-axis. Or it's going to be upside down, or it's going to flip, or whatever you want to refer it. But I like to think of it as if someone is positive, it's pointing up, happy face. When someone is negative, sad face, it's pointing downward. Okay? And that's where multiplying it by a negative or multiplying it by a positive points up or points down. All right, let's talk about our last transformation. Okay, this one is the one that's the least common. The least common transformation. And now we're also multiplying it, but instead of multiplying it on the outside, we're multiplying within the function. So inside of the function, we're going to multiply it times a factor of b. Right now, we have a 1 inside, so it's just 1 times x. It's just the original one. It stays as it is. But as you start increasing this value, this looks like, right, what's happening here as we're going up there. It's going to look like the previous example. It's going to get narrower. But now we're looking at the function where you're dealing with the inside. We're now going to refer to it as a horizontal transformation. So inside is going to be a horizontal transformation because you're affecting the x value. And the x-axis, if you think about it, the x-axis is horizontal. Previously, we are multiplying it on the outside. What were we affecting? We were affecting the y value, the f of x. When you're affecting the y value, y's are vertical. X's are horizontal. Okay? So we're going to talk about the same transformations, but now we're going to talk about it in terms of a horizontal stretch or as a horizontal compression. Okay? So you can think of this as your hands. The parabola is your hands. If the number gets higher, right, what's happening horizontally as the number increases? As the number increases horizontally, you're bringing your hands together. Okay? Vertically, your hands are going higher, they're stretching, but horizontally, your hands are coming closer together, right? You're hugging the y-axis. So we call this a horizontal compression. Okay? We're squeezing your hands together. It's compressing horizontally. So let's say that the general function is f of, let's choose a number here, 4. Let's go higher. Let's go 5. 5 times x. When the multiplication happens inside, we say this is a horizontal compression. Also by a factor of 5. By a factor of 5. Whatever you're multiplying it by, it's going to compress horizontally. If you're doing a vertical stretch, right? You're stretching vertically, but horizontally, what's happening with your hands? They're coming together, which is a compression. Okay. Now, what happens when it's smaller than 1? Right? As we go back to the original one, where it's equal to 1, as it starts getting into the decimals, it's getting wider. But horizontally, right? If we're looking at earlier, we were squeezing closer to the y-axis. Here, we're pulling further away from the y-axis, right? Your hands are horizontally stretching now because they're going further apart. A vertical compression happens when your hands are squeezing together vertically. Your hands are closer together. Look at one hand and look at the other. They're coming together. Here, your hands, as you stretch horizontally, your hands are going wider apart. We call this a horizontal stretch. Okay. And here we're going to say, let's just say some number. Let's do like 1/5 or a decimal, right? We can multiply it by something. Let's say 1/3 times x. So you're doing a horizontal stretch by a factor of 1/3. So what am I doing horizontally? I'm squeezing them or I'm stretching them, right? My hands are squeezing together, a compression, or they're stretching further apart horizontally. The previous example, again, was vertically. Vertically, we're stretching them here. We're getting them higher up vertically. And then vertically, we're going wider and wider and wider. All right, let's talk about what happens when it equals 0. Like before, what happens if I multiply something times 0? It changes the functions to a linear. Like the quadratic completely disappears and it becomes a line. So multiplying anything times 0 is going to change the function from a parabola to a linear. The function completely changes. It just equals 0. Hence being on the origin. All right, lastly, what happens when it's negative? If we start going towards the negatives, right? This one is the least, this is going to be the least, what's it called? Popular transformation. In our previous example, when it was negative, right, it was positive, it's pointing up. When it's negative, it's pointing down, up versus down. When it's on the inside, you can't really tell the difference here because notice how it never goes to the bottom, right? Negatives or positives. What's happening here, when you have a negative, you're actually flipping the picture from one side to another. So the right side of the graph is going to reflect over the y-axis, and the left side of the graph is going to flip over to the other side. Because the parabola is symmetrical, it looks like it doesn't really change. It looks like it's the same, right? But by moving into the negatives, you're just going to flip things over to the left and to the right. So this is not a reflection over the x-axis. This one is a reflection over the y-axis. So f of some number that's negative number times x. Right? We're flipping it over, but across the y-axis. And before, we were flipping it over the x-axis because we're multiplying the function by a negative. On this example, we're multiplying the x value within the function times a negative. So it just flips it over, right? It flips it over across the y-axis. It's easier to see whenever the parabola is over here. If it's on this side, it flips it over to this other side. It's easier to see in that transformation. So let's put this whole thing together and let's do an example. How can you put this to use so you can remember all of these rules? I'm going to show you a calculator trick that will show you how to go about this process when you're trying to plug it in. Okay, so here's our scenario. If I want to go and figure out, compared to its parent function, f of x equals x squared, what effect will we see in the graph when the function is adding 4? Okay, I'm going to create a new tab here. I'm trying to open this up here on the side. Give me a second. Give me 1 second. All right, so I'm going to go to the graph. I'm going to type in here under f of 1, x squared. This is the parent function. Okay? I want to change this parent function. We're going to call this f1. f1 of x, and my calculator will be stored as x squared. I want to know what happens when I take the parent function, so f1 of x, and we add 4. So we're going to add another function here. When you press plus and the tab, you can go up and down on it. Right? So tab down moves to the different functions, up moves up to the functions. So f1 is already taken. We're going to go to f2, and we're going to add 4. So we're going to type in the function f of x. This is f1. We're going to call it f1 of x. We're going to do plus 4. What happens when we add 4? The new function, notice how the function moves up. So we call this a vertical shift up 4 units. What did I do? Well, let's go back a little bit. We press tab up, and we can navigate the function completely. Let's erase this again. My original function is f1 of x. I'm going to add another function, call it f2. So the second function is going to be the new one. So we take the old one, f1, and we do plus 4. And it tells you that it moves up 4 units in the picture. What if it was a minus? We could go here and we change this to minus. The problem says take the function and subtract 4. Now it's going to move down 4 units. Instead of being at 0, 0, it'll be in the negative. All right, and I can do this for anything. I can multiply the function times 4. So 4 times, it's going to get vertically stretched. I can do whatever I want at this point. Instead of multiplying it times 4, I can do minus 4 inside the parentheses, and it's going to move it 4 units to the right. Right? Remember, inside the parentheses, it's always the opposite behavior. All right, guys, I hope this has helped. If this video helped in any way, make sure you click the like button. And if you haven't already, subscribe. And as always, we'll calculate later.